Okay, guys, section 4, okay? Section 4, applications of per capita and proportion. Actually, this section 4 is an extension section from section 3, okay? So it's good that we do both sections together today, okay? Because you will see that we're still studying per capita, we're still studying proportions, okay? It's just more words problems, more applications, okay? Okay, so section 4, okay, we are going to do the entire page of page 35. Okay, so this is page 35. We'll do the entire page of 35. Okay, next page, guys. Entire page of 36. Okay, it says about GDP. Okay, we'll talk about GDP. Okay, all right. On page 37, okay, we have the discover part, okay? Yeah, I want you guys to read the discover part, okay, because there's no question, so what we can do is just read it, yeah, but we'll still cover the discover part, okay? The Excel part, this is the first time that we see the Excel part. Remember at the beginning of the class, I said Excel part are the self-practice self-study part, okay? So this is a self-study. This is also your homework assignment, after class, okay? You are going to self-practice. Well, if you have a laptop with you today, okay, later, in class, after we're done for the lecture, you can also self-practice by yourself on your own laptop, okay? But this part, we don't cover this in class, okay? We don't do it as a lecture in class, okay? So I want you to self-practice it, okay? So page 37, you self-practice. Page 38, still Excel, self-practice. Then let's move on to page 41. Page 41, we talk about the CPI, okay? So entire page of page 41, okay? We will read discover part, and also we'll work on the questions from the connect part, both question 1 and 2, okay? So entire page 41, okay? And then on page 42, okay, we do question 3, A and B, okay? Okay, I believe that's it for section 4, okay? Okay, so now let's go back to what page? 35, yes, you're right. Okay. All right. So this question is about the proportion expectations. So this is also a proportion problem, okay? So we have a table here, okay? I'm going to ask a volunteer to read these short paragraphs, this table with numbers. Is challenging, right? And also, we're going to work on question 2, A and B together, okay? So you are going to read all of these, okay? One student read all of these. This paragraph, this table, and also question 2, the questions, okay? Now let me see whose turn, okay? Let me see whose turn. Damon?
We can also use proportions to consider what-if scenarios. Consider the table on the right, which contains the full amount of money spent on K-12 education for the 2014 to 2015 school year. Indiana was 9.97 million to the population of 6.6 million. Illinois was 28.54 billion to the population of 12.9 million. Kentucky was 6.58 billion to the population of 4.4 million. Michigan was 16.85 billion to 9.9 billion population. Ohio was 20.23 billion to the 11.9 billion population.
Question 2. Can you read this question?
Use the value of K-12 education expenditures in Ohio as a proportion of the population of Ohio to estimate the value of K-12 education expenses. European Kentucky.
Question 8.
Find expected value of the K-12 expenditures in Kentucky if Kentucky were proportional to Ohio? How does this compare to the actual value for K-12 expenditures in Kentucky?
Okay, very good. Thanks. Okay. Okay, so we're pretty much going to use this table and solve our question 2, okay? So in this table we have different states, okay, different states. Well, in question 2, how many states are involved in question 2? 2 states, right? One state is what? Ohio. And then what's the comparison states? Kentucky, okay, Kentucky. So, from the table, for this problem, we'll only need to use the data from these 2 states, okay? So, let me copy down the data in the open area so we don't have to move this page up and down, okay? Alright, it says, for Kentucky, I'm going to write it here so you guys can see, okay? Kentucky, the expenditures is what? 6.58 billion. What is the population?
4.4 million.
4.4 million. I'm going to write it down here, okay, is the data. Okay. And then for Ohio?
20.23 billion.
20.23 billion.
6 million.
And 11.6 million population. Okay, so now let's reread this question again, okay? We're doing question 2, okay? A and B. Use the values of K-12 education expenditures in Ohio as a proportion of the population in Ohio to estimate what the value of K-12 education expenses would be in Kentucky. Yeah, so find the expected value of K-12 expenditures in Kentucky if Kentucky were proportional to Ohio. Proportion problem. So for proportion problem, we know that we talked about in section 3, it's an equation of 2 ratios, right? 2 ratios. Now I'm asking you guys, we have this 1, 2, 3, 4 data. Okay? Yeah, 2 data are for Kentucky, 2 data are for Ohio. Now my question is, which state is a sample state? That means we're going to use both data from this state. Ohio. Why Ohio? It says we want to find the expenditures in Kentucky if Kentucky were proportional to what? Ohio. So Ohio is what? Our sample. The Kentucky were proportion to it, right? So Kentucky, that means for Ohio, we're going to use both of the 2 data from Ohio, and Kentucky will proportion to the state of Ohio, right? Okay, then guys, how to build this proportion? We can put Ohio on one side, okay, Kentucky on the other side, right? It doesn't matter whether you put Ohio on the left or you put it on the right. It doesn't matter, okay? So let's say we put Ohio on the entire left, Kentucky on the entire right. This right side is for Kentucky. And then for the Ohio, this state, there are 2 data, right? One data is what? Expenditures. The other data is what? Population, okay? So on the top and the bottom, if we put expenditures on the top, which is what? 20.23 what? Use Ohio's, okay? Because this side is Ohio. Billion. And then we put a population, which is 11.6 what? Million. So this is already one side of the proportion, right guys? Okay, on the other side for Kentucky, what quantity are we looking for? Yeah, expenditures, right? So we know the Kentucky expenditures is X. My question for you, I want to put this X on the top or on the bottom? Why on the top? Because on the left side for the Ohio, expenditures is on the top. So put X on the top. Everybody agrees with that? All right, on the bottom, we're going to use Kentucky's what? Population. So which data should we use from the given data? 4.4 what? Million. Okay. Well here, what will be the unit for X? Billion. Okay, yeah, billion. So on the bottom we have both millions, they cancel out. Okay, on the top we have both billions, they cancel out. So eventually when we do the calculation, you don't have to keep the units. That's simpler, okay? And you know the X value we compute, the unit will be in billion. Okay. All right, so that's good for the proportion, everybody? Okay. Now once we have the proportion, how can we solve for X? Same thing, cross multiplying. Okay, so we will have 20.23 times by what? 4.4 equals 11.6 times by what? X. In order to isolate X, we divide by 11.6 from both sides. Use your calculator, okay, and give us an answer, okay? So X equals okay, what do you get for X? Please let me know. Nobody knows?
7.67.
Okay, 7.67. Everybody get the same answer? Okay, well here, you can write 7.67, or you can round to, yeah, 7.67 is better, okay, because this is a big number, right? If we round up or down, it's going to be too much different, okay? So yeah, let's use 7.67, and then what? What is the unit for X? Billion. Okay, 7.67 billion. Guys, let me ask you this question. What is this 7.67 billion, the result mean? Means what? According to Ohio's, okay, a proportion to Ohio State, Kentucky are expected to spend how much? 7.67 billion on their what? Education expenditures, right? And how about this number, 6.58 billion? What does this number mean? That's the actual number. This is a what? Expected number, right? So this number is expected. Okay, now question B. How does this compare to the actual value for K-12 expenditures in Kentucky? This number compare with, the actual one, it is higher or lower? Higher. So that means Kentucky should spend more according to what? Ohio. But actually, it's not. Okay? So higher than what? Than the actual value. Does this make sense, guys?
So Kentucky spends less per capita for education.
Yeah, actually spend less. Yes, yes, you're right. Because this number is expected, but they don't meet the expectation, right? So actually, Kentucky spend less per capita, than in Ohio. Very good. Okay, so this is question 2. I want you guys to try this unfinished example, even this example unfinished, and also this question 1 in group by yourself, okay? All right, guys, now let's turn to page 36. GDP per capita. Please do pay attention to the problem because you'll encounter homework assignments similar to this. You might also encounter an exam question similar to this, okay? All right, so GDP, okay, and GDP per capita. I'm going to ask a volunteer to read the concept for us. Okay, now let me see whose turn. Amanda?
Yes. Okay, gross domestic product, GDP, is a market value of all officially recognized final goods and services produced within a country in a year. GDP per capita is the market value of all officially recognized goods and services produced within a country per person, and GDP per capita is often considered as an indicator of a country's standard of living.
Okay, very good, thanks, okay? Yeah, GDP per person is often considered an indicator of a country's standard of living, okay? So if a GDP per capita is higher in the country, that means this country's people have a better standard of living, okay? But if GDP per capita is lower in some country, that means their standard of living is lower, okay? Because on each person, the GDP is high, means you can spend more money, okay? So similar to that, okay? The idea is that like that. Now we have these countries, okay? So we have these 5 countries, okay, GDP per capita, okay? We have the GDPs from each country, okay, in billion of dollars, okay? And then we have the populations from each country. And then here it asks us to compute GDP per person, okay? And then we're going to answer what? The following questions on page 36. Well, here, I'll only show you, okay, about 2 lines to compute GDP per capita, okay? Once you're able to find GDP per capita, you should be able to answer the following questions, okay? So, now let's look at the first 2 lines about how to find GDP per capita. Australia, total GDP 1532 billion. Total population 22 million. How about GDP per capita, guys? How do we compute the result? Any suggestion? Per capita, population is always on the bottom, right? So we have a 22 million, 10 to the 6. On the top, we have a 1532 billion, 10 to the 9th. See? Division of the numbers, right? 1532 divided by 22. Use your calculator, please. Have you got an answer here? You guys, who has a calculator?
69.
What?
69.
69? 69 times 10 to the 3, 10 to the cube? Everybody? Well, what is needed for this number? In dollars, right? Dollars, okay. So, 69 times 10 to the cube. Everybody get the same answer? I don't have a calculator, okay? So whatever you tell me, I'll consider you get it. What?
Okay, so with this, do we ignore what comes after the decimal? Just, so it'd be 69.6.
69.6. You got 69.6?
Yeah.
Oh, okay, so 69.6 times 10 to the 3, okay? Well, here, it doesn't say you have to write your number in scientific notation. So I would think that either you rewrite it as 6.96 times 10 to the 4th power, or you could rewrite it in a standard notation. What is 69.6 times 10 to the 3 in standard notation? $69,600. This makes more sense for us, right? Because 10 to the 3, we don't know what is that, right? 10 to the 4th, we don't know that. But if we write it in a standard notation, oh, you know that per person, the GDP for Australia is what? $69,600. This is higher. I think this is higher than United States, right? I don't know, okay? We can compute it, okay? United States is here, okay? You can compute that, okay? This is this many of the billions, and this is this many of the millions. You do the exactly same thing, mimic this line, you can get a number. I couldn't remember. So, but very likely, Australia is higher than United States. You can try it, okay? Later in class, okay? Later. All right, let's practice one line. Canada, this is GDP, this is the population. Oh, guys, how about we try the line of number 3, the China? Because there is a question 4, we can do the proportion, okay? Yeah, so Canada, you can do this by yourself. Let's do the China line. Compute GDP per capita. What do you get here, guys? 6 point something, right? 6.099? 0.094? Okay. 6.094 times 10 to the cube. If we rewrite it in the standard notation, it is $6,094 per person. 69,000, 6,000. Almost 10 times, about 10 times, right? You see the difference? So that means on each person, okay, per each person, China's GDP is 6,000. And in Australia, each person is 69,000. You see that this is a huge difference, okay? And then you can answer the question 3 by yourself. And it says, oh, GDP in China is so strong. It's just total GDP. But why per capita is so low? Because the population is huge. That's the reason, okay? So you can answer the first 3 questions and then question 5 by yourself, okay? Now let's practice question 4 together. I'm going to ask a volunteer to read the question for us. Andrew? Ready? Kathleen?
For 4,
Mm-hmm.
if China's GDP were proportional to Australia's, what would China's expected GDP be? How does this compare to the actual GDP in China?
Okay. Proportion problem. How many countries are involved?
2.
2 countries, right? What are the 2 countries? China and Australia. Which country is a sample country? China were proportion to Australia. Which one is sample? Australia. So let's put Australia, 2 countries on each side. This is China. Okay. So Australia on this side, China on that side. Australia is a sample, right? Sample. So we're going to use data from Australia. Okay. We're going to use a GDP. We're going to use a population. Okay, population from Australia. So GDP is 1532 in billion. Okay, billion. Population is 22 million. What would China's expected GDP? Okay, so GDP is on the top, population is on the bottom. So what would China's expected GDP be? We don't know. So we let it to be X. On the bottom should be China's what? Population, right? So 1350 million. Can you guys follow me? You guys? Okay. Of course, the unit for the X is also in billion. Cancel out the unit. Cross multiplying. Get X. That's the expectation. And then you will be able to compare the expectation result to the actual GDP in China. Okay? I'll give you 2 minutes to compute. Okay? First multiplying, compute X. You really should have a calculator with you in class, right? Because without a calculator, you're not able to compute this.
Calculator is in my head, right here. No, I actually have one here. Yeah.
Okay, so what's your X value, guys? Has anybody got a X value? About what? 6, 9, right? Nobody get an answer? No? Really? Can I borrow anyone's calculator?
Yeah, that's not what I got.
You got what? You got a, okay.
Yeah, I got
94, okay. Yeah, 94, yeah, you may be right, yeah, you're right. 1532 times what? Times, what is that, 1350? And divide by what? Divide by 22? Okay, 94 and 9, right? You're right. 6. So, $94,009 billion, okay? Billion. And then this is the expected value, right? Expected. how does this expected value compare with the actual GDP? The actual GDP in China is 8,000 something, right? So you can answer, the expected GDP is much higher compared with actual GDP, okay? So it is much higher compared to the actual GDP. Everybody clear about this problem number 4? You see, number 5 is very similar to number 4, so that's why I give you an example about number 4, so you can mimic and do question 5, okay?